In the next 6 minutes, you are going to make a program that controls this servo motor using this potentiometer. Hi, my name is Jeremy, and welcome to the 7th tutorial in a series of videos aimed to teach the basics of using an Arduino microcontroller so that you may compete in this semester's Solid-State Circuit Society Arduino contest. More information available in the link below. If you have not already, check out our previous videos as this one will build on their material. Last video, we discussed DC motors. Today, we will discuss servo motors. This device has 3 connections, typically colored brown, red, and yellow, corresponding to the negative, positive, and control signals. If your colors do not match, do a quick Google search using your servo motor's part number to locate its data sheet. This document will identify the 3 connections. Let us connect the negative wire to ground, the positive wire to 5 volts, and the control wire to one of our Arduino's output ports. Similar to last video, where a PWM signal controlled the DC motor's speed, here a PWM signal will control the servo motor's rotation. However, servo motors use a slightly modified version of PWM. Whereas conventional PWM uses a period of 2 milliseconds, servo motors expect a period of 20 milliseconds. Furthermore, whereas typically the duty cycle may vary anywhere between 0 and 100%, with servo motors the range must be limited to within 5 to 10%. In other words, by sending a PWM signal with an on time of 1.5 milliseconds or a 7.5% duty cycle, the servo motor will point straight forward. If we reduce the on time to 1 millisecond or 5% duty cycle, the servo motor will point 90 degrees to the right. And similarly, if we increase the on time to 2 milliseconds or 10% duty cycle, the servo motor will point 90 degrees to the left. Let us build a circuit that measures the rotation of a potentiometer to control the angle of our servo motor. Disconnect your Arduino and rebuild the analog sensing circuit from tutorial 4. I will connect the potentiometer wiper to analog port A0. Next, let's add the servo motor. Connect the negative side to ground, the positive side to 5 volts, and the control signal to one of the Arduino's digital outputs. I will arbitrarily use port 4, but you may use any of these ports. Indeed, when it comes to servo motors, we are not limited to the typical PWM output ports. In fact, we may use any of the digital output ports. Next, let us write the code. Today we will reuse the program from tutorial 4 used to sense the rotation of our potentiometer, and then make use of the Arduino servo library to control our motor. Begin by defining both the input and output ports, in my case A0 and 4. Then, in the setup function, initialize your input port. Type pin mode input port input. To read the potentiometer, in the loop function, type int val equals analog read input port. Next, we will import the servo library. At the top of your code, type #include servo.h. For those who are not familiar, a library is simply a collection of built-in functions. By including this library, we are now able to use functions that the compiler would normally not recognize. Then, define a variable that will be used when talking about the servo. I will arbitrarily use the name myServo, but you may call it any name. Type servo myServo. To initialize our output port, in the setup function, type myServo.attach output port. Then, to send the modified PWM signal, in the loop function, type myServo.writeVal. Add a small delay with delay 100. Similar to last time, we must modify the variable's range. In this case, The servo write function expects a range anywhere from 0 to 180, corresponding to 0 to 180 degrees of rotation. Between the write and read functions, add our map function. Type val equals map val 0 1023 0 180. And we're done. Plug in your Arduino and upload the program. If successful, by rotating the potentiometer, the angle of our servo motor should change. If so, then congratulations! Feel free to play around with the servo motor. I challenge you to make spin art. Use your DC motor from last tutorial to spin a piece of paper. Then, use the servo motor from this tutorial to control a marker and draw beautiful art. Join us next video when we will build a counter using this 7-segment display.